Welcome to lesson 8.2, and in this lesson we're going to be proving right triangles on the coordinate plane. And what do you think we're actually going to be doing in this lesson? Well, that's right. We're going to be looking at the coordinates of a triangle and proving that it's a right triangle. Did I just blow your mind? Yup, I did. All right, so let's take a look at this for a problem. Let's just take a look at this and see how could we actually prove, just given three stupid little coordinates, that something is a right triangle. How can we do that? Well, I'll show you. So in the coordinate plane, the vertices of triangle ABC are A, 0, 3, B, -4, 1, and C, 6, 5 prove that this is a right triangle. And we are going to prove it. And we're going to do it using mathematics. The way we're going to do it is by first following step 1, which is just plotting the points. All right, so we have A over mya, we have me over at -4, 1, and then we have our C at -6, 5. All right, so we got our 3 points, and we're just going to graph out our triangle here. Now, if you're looking at this the way I am, I'm like, duh, that's a right triangle. It looks like one. But that is not a proof, right? I can't just draw a right angle over here and call it a day. We are actually doing something much more rigorous. We are proving. And to prove that this is a right triangle, what we are going to do is actually just find the slope of all three sides. Okay, so we got AB. We have AC, and we have BC. We're going to find all three slopes, and then we're going to show that two of those slopes are perpendicular. Because if I could show that two slopes are perpendicular to each other, two lines are perpendicular to each other, then I know that they intersect to make a 90-degree angle, which is the definition of perpendicular. And if I've shown that I have a 90-degree angle, then that proves that it is a right triangle. See the logic here? Hopefully you do. So let's go about finding all our slopes. Now the way to do that is we are actually just going to use our good old friend, the slope formula. All right? Oh, wait, no, that's too much work. Why don't we just be lazy? Why don't we just count? So to find the slope of AB, let's just find the slope by counting. So I go left to right always, over 4 up 2. And if I go over 4 up 2, my rise is 2. My run is 4, and we're going to reduce that over to 1/2. Okay, so that's our first slope. Now our second slope is AC, so we're just going to once again count left to right. 1, 2, 3, 4, 5, 6, 6 over, 2 down. So if I'm counting down, don't forget the negative, very important. So my M2 over here is going to be -2 over 6, which we can just reduce down to -1/3. And for our third slope, which is BC, we're just going to count once again. Left to right, we go down 1, 2, 3, 4, over 1, 2. Okay, so our M3 is equal to -4 over 2, which is just, that reduces to -2. Okay, so these are our three slopes. Now, are any of these two slopes perpendicular slopes? And sure enough, if you look real carefully, you see that our two slopes that are perpendicular are AB and BC, right? We have these two. 1 over 2 is perpendicular to -2. And so we're actually going to connect those and show that they are perpendicular. All right, so that's the first thing. We found the slope and showed that two sides are perpendicular. But we're actually going to write out a full conclusion. We're going to be great students now. So now that we found our slopes, we're going to write a conclusion that demonstrates that we totally understand what's going on here. So we know that triangle ABC is a right triangle because AB is perpendicular to BC. And that is enough. Now don't forget, you should do your proof exactly as the way it was done here. First, you got to show your work. Always show work. I can't emphasize that enough. So you show your math. And then 2, you're going to write out that. Don't forget to write out your conclusion. All right? Always write it out. You know it's a right triangle. And be specific. Which two sides do you know are right angles? So since BC and AB are perpendicular, they create this right angle right here. And this is, in fact, a right triangle. Nicely done, guys. We did a great proof there. Let's move on to all right. So for this part, we're going to find the missing coordinate of a point, okay? And this is a little bit different. It's a little hard, but not too bad, okay? So you're going to be doing this the rest of your like other lessons in this unit. So for this one in the coordinate plane, we know that vertices of triangle ABC are AX3, but I put that in wrong. Please make that a 2. Change that to 2 right there. B is 4, -2, and C is 8, 4. For what value of X would this be a right triangle? Well, let me show you how to do this one, okay? We're actually just going to do a little bit of counting. So what we're going to do is plot our known points. So let's put a little note there. Plot known points. All right, so we got 4, -2, and 8, 4. That's B, and that's C. Now, A, we know we have a Y value of 2, and we don't know the X. So if my Y value, which is right here, is 2, I know somewhere where Y equals 2, I'm going to have my next point. And what you should do is draw this dotted line. If it's Y equals 2, your Y equals 2, you actually draw a line at Y equals 2. All right, and we know the point is going to be somewhere on that line for A. So what you do now is actually, there's no real math, it's just counting here. So what we're going to do is to prove that, to find the missing coordinate, we just have to make a right triangle. We need 2 lines to be perpendicular. So what we're going to do is just count. We're going to count the slope of BC. So if you counted the slope to BC, B to C, left to right, we would have to go up 1, 2, 3, 4, 5, 6, and to the right 1, 2, 3, 4. So we have a slope of +6, 4. Okay? Now to find the missing point, what we're actually do is just go perpendicular. And so we're just going to flip it. So if my slope of BC, the slope is 6/4. The slope of AB, I'm going to start counting from B, is going to have to be -4/6. All right? I'm just flipping it over. So what you do is this. You're just going to flip it. So instead of your rise being 6, your run is now 6. So watch. We're going to start at B. I'm going to count over 6. 1, 2, 3, 4, 5, 6. So I go left 6, and now I'm going to go up 4. 1, 2, 3, 4. And that is where my point A is going to be. All right? And you can draw that out like so. And now you have created this beautiful right triangle. Okay, and sure enough, if you look at this, my slope is -4, 6 for AB, and I've done it perfectly. So the answer to my question, we know that A is going to be at point -2, 2, and so X is equal to -2. All right, so it's just about accounting. It's kind of like you got to figure out where it is by counting over. Let's try that again, okay? Let's try that one more time. I know that can be a little difficult for people, okay? So the coordinates of vertices of RTS are R, -2, -3, 8 is 2, 2, 8, 2, and T is -6Y. Find the value of, there are so many little mistakes here, Y that would make this triangle a right triangle. All right, so we're going to do the same thing again. So we're going to plot our known points, which are R and S. So we're going to plot points. So we know -2, -3 is our first point. That's our R, and S is 8, 2. And that is our S. All right, so you connect that. And our T is going to be somewhere where X equals -6. Okay, so since X equals -6, we'll go to -6. And I'm just going to draw a dotted line at X equals -6. Because somewhere on this line is where my point is going to be. Okay? So we do exactly what we did last time. We're going to count the slope of RS. So our slope for RS is, well, we go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our slope is 5 for 10, which reduces, because we always reduce it to 1/2. All right? So the slope of, let's see, my next point is T. I'm trying to find T, so I'm going to be finding RT is going to be, we got to find the perpendicular slope, which is going to be -2/1. All right? So, just like before, what we're going to do is reverse it. Instead of counting 5 up and 10 over, or in this case, 1 up and 2 over, we're going to do the opposite. We're going to count 2 up and 1 over. So we're just flipping it, right? We're going to count 2 up and 1 to the left, okay? So I'm going to go 1, 2, 1 to the left, 1, 2, 1 to the left, 1, 2, 1 to the left, 1, 2, 1 to the left. And that is where my next point is going to be. So this is going to be point T. So you see here the x is -6, all right? And my point is -6, 5. So we're going to connect this. We have a beautiful right triangle now. So the point T is at -6, +5. And so y was equal to 5. All right? So that takes some practice to get good at it. All right? But I think you'll do it. So just to give you a little, I think that covers it. So that's how you find the missing point. You know how to prove something's a right triangle, and that is it for this lesson. My tip for today is don't lose your keys, because then you'll be locked out for 3 hours at Starbucks waiting for your wife to get you back in. Not that I know, but I do. Bye.